In continuation to our discussion on plasma properties of the geospace, in this lecture, we will try to see what are plasma oscillations. It is very important for us to understand plasma oscillations at the very basic level because plasma oscillations can be very helpful in understanding many ionospheric phenomena. The conductivities or the drifts, anything related to ionosphere can be understood by the plasma oscillations. Right now, in the last lecture, I have introduced what is called as quasi-neutrality. We're not calling complete neutrality, we're calling it as quasi-neutrality. So before understanding plasma oscillations, it is very important to understand what is quasi-neutrality. Okay. Now let us say we have a plasma, we have a gas in which electrons and ions, the number of electrons are given by Ne and number of ions are given by Ni. Okay. And let us say if these two are in equivalent numbers, Ne is equal to Ni. So as a result of this, we can simply write the total charge density rho is equals to Ne number of electrons with a negative charge of minus E each plus Ni number of ions with a positive charge plus E. Okay. Now, as long as Ne and Ni are equal, this equation will simply be 0. But rho can be written as E times Ni minus Ne. What is this? Rho is the charge density, N is the number of electrons or ions per unit volume, E is the charge of electrons. So the total charge density, the total charge that can be present per unit volume is equal to the difference between the number of ions and electrons multiplied by the charge. Right. Let us say we call it as E times delta N. This is on the macroscopic scale, looking at the entire plasma. It is always a neutral entity. Although there are enough number of electrons and ions, there are charged particles. Plasma is not electrically negative or positive. It is a neutral entity, but it gets influenced by the electric and magnetic field. That's where it becomes very interesting. Okay, now let us say for some reason this density rho is not equal to 0. Okay, let us say. Now, if density is not 0, if there is charge density, then we will always get an electric field. Right. So, when you have charge contained in a volume, we know the Gauss law. It says there is an electric field which can be obtained by using the Gauss law. It is 1 by epsilon naught times the charge that is enclosed. Right. So, we can use that. So, there is an electric field because of non-zero charge density. So, we can write the Gauss law del dot E is equals to rho by epsilon naught. Right. Del dot E is equals to rho by epsilon naught. Let us say we look in one direction. We write as dou E by dou X is equals to E by epsilon naught times delta N. I have used this here. Okay. So, E can be obtained. So, dou E by dou X, because we have taken only one term from the gradient. Dou E by dou X is E by epsilon naught delta N, right? So, E, the electric field E is Ex divided by epsilon naught delta N. Or X rho by epsilon naught, same thing. Right. Now, there is an electric field. So, we can also define a force. Now, we are referring to things per unit volume. So, it's appropriate to say that this is the force per unit volume. Okay. because delta n is carrying these dimensions, right? F is equals to E times Q. We know this. We will write this in such a way that we will write it as E times rho, which will be substituting what we know for rho x by epsilon naught, right? What we know for E, we can write it as force is rho square x by epsilon naught, or force is equals to E del n square times x divided by epsilon naught, right? Now, what is this? What have we done? We have introduced plasma with electron density and ion density. We said maybe they are not equal. If they are not equal, there should be some charge density. The charge density should generate an electric field, and this generated electric field should produce a force. As simple as that. So, what is x here? X can be assumed to be the distance over which these two charges, the charge inequality is existing. Okay, so F is the force which will act along this particular distance, right? Now, delta n is, of course, what is it? Delta n is the difference in the number of electrons and ions, right? Now, using this simple expression, we can say that let us assume that there is a very small difference in the electron and ion densities. Okay, let us say there is only 1%. 1%. Okay, so delta n by n is 1%. I'm talking about percentage, right? Which means number of ions or number of ions are larger than the number of electrons by 1%. So, for every 100 electrons, there is one ion which is extra. Okay, and let us assume the charge separation, because there is unequal charges. These two charges are separated by a very small distance, which is 0.10 meters. Okay, you understood? So, how much is the separation? Separation is 0.10 meters, 0.1 meters, and how much is the difference in charge, difference in the number of charges? In percentages, it is 1%. Okay. Now, let us assume a plasma which is the density of the plasma is 10 to the power of 19 electrons per unit volume. Okay, so which is Ne. Okay, and if you want to calculate Ni, it will be 1% larger, which is 1 by 100 times 10 to the power of 19. Right. So, fine. Now, with these simple numbers, we will calculate how much amount of force will act on the plasma. So, it will be, the force will be, which will be 1.6 10 to the power of minus 19, which is the charge of electron, multiplied by, I said 1%, I said 1%, right? So, 1 by 100 into 1 10 to the power of 19 times 0.1 meters divided by epsilon naught, 8.85 10 to the power of minus 12. So, if you calculate this, the force which is acting along the distance of 0.1 meters, what is the objective of this force? Why this force is acting? This force is resulting from an electric field which is due to the charge separation. Okay, this force will be 3 10 to the power of 6 Newton per meter cube. Okay, now if you are wondering what am I doing, let us quickly recap what we have done. Okay, so we are looking at the fundamental idea of quasi-neutrality, where without that, plasma will not have equal number of electrons and ions. Let us say we have a situation in which number of electrons and ions are not equal, then there will be an effective charge or charge density, which can be obtained by using this simple expression. And if there is a charge, we can calculate the electric field resulting from the charge density, and subsequently we can also calculate the force which will be acting along the distance of separation between those two points. And we got this simple expression, and if we substitute something that we considered a specific case, let us say we are talking about a plasma system in which there are 10 to the power of 19 electrons and ions. The one of the charge carrier is smaller by a percentage of 1%. Okay, and this charge separation is existing over the distance of 0.1 meters, right? Now, if all of that was correct, then the amount of force which will act is huge, 10 to the power of 6 Newton per meter cube. So, if there is charge separation, incredible forces will be created within the plasma. Why? What is the objective of this force? The objective of this force is just to neutralize or bring neutrality into the plasma. So, the most fundamental property of plasma is its tendency to remain electrically neutral. Okay. How it achieves neutrality is going to be answered in terms of plasma oscillations. But the most fundamental property of plasma is actually its tendency to remain electrically neutral. Okay. And any small change in the neutrality results in setting up electric fields, very large electric fields, which will pull the electron back to the initial position. So let us say you have you remove some electrons from the plasma, not from the plasma, from one place to the other place. Okay. If these electrons are existing here, then we have a neutral, everywhere it is neutral. But if these electrons are removed or dragged away by a small distance, now in this region, the number of electrons is very large in comparison to the number of ions. As a result, what happens? A large scale electric fields are set up, and which the motivation, say electric field will be set up. Electrons will always move in the opposite direction to the electric field. So, this electric field will try to pull these electrons backwards. And when it is being done, these electrons have some mass, right? And the electric field or the force will attribute some velocity to these electrons, and this velocity combined with the mass will we are talking about inertia. So, electrons being brought back by their force, because of the inertia, they will always overshoot the original position. I mean, I'm not drawing it beyond the system itself, but now we can safely assume that the electrons are being electrons are overshooting the initial position. So, what happens immediately? The electric fields, now there is abundance of electrons here. So, immediately electric field will be created in the opposite direction, and electrons will be drawn towards the other side. So, as a result of this, electrons will again overshoot. So, this movement of electrons back and forth will create what are called as the electron plasma oscillations. Now, if you can spend some time, why these oscillations are existing? Because electrons are moving. Why electrons are moving? Electrons are moving to compensate the disparity in the charge densities, or to compensate the difference in electrons from one place to another place, which means, so this oscillations are plasma's natural ability to regain or to establish charge neutrality. Okay, and this movement will repeat, of course, will go on, and in the absence of any damping or any collisions, these motions will continue forever. Okay, so as a result of which, there will be some, we can identify a frequency. We can identify a frequency of plasma because there are oscillations, right? There will be some frequency, and this frequency has to depend intricately or explicitly on the properties of plasma, on the fundamental properties of plasma, which will define what type of plasma it is, whether it is hot, cold, whether there are collisions or not, whatever. Right. So, in the absence of any damping, these collisions will go on forever. And in this process, neutrality is now being maintained. So, this oscillatory behavior of plasma leads to the idea of plasma frequency or plasma oscillations. Now, let us derive an expression for the plasma frequency. Let us consider uniform plasma with number of electrons equal to number of ions. Okay, equal to the number of ions, which are equal to the number of neutral species. Okay, NO. Assume that the plasma is cold, which means there are no collisions in the plasma, and random thermal motions can be neglected. Okay, and let us assume a one-dimensional slab to establish or to describe the motion of particles. Let us say we have one-dimensional slab. Okay, in this slab, everywhere it is neutral. What does it mean? If it is neutral here, I'm actually referring to the number of ions in this region is equal to the number of electrons. Okay. Now, what I do is by applying an external force, I'll slightly modify this picture. By applying an external force, you still have the neutrality maintained here. By applying an external force, I'm pulling or I'm moving a section of electrons from here. Let's say we call it as region 1 into this. Okay. Now since the electrons are being taken away from the region 1, this region is effectively negatively charged, and again here the other side of this region, it is neutral. So this is the place where action is going on, right? So electrons are moved from here to here, and the region 2 is negatively charged and region 1 is positively charged. As simple as that. So how do you expect the electric field to be? Electric field will be in this direction. Now electrons have to move opposite to the direction of electric field, so they will move in this direction. And because of the mass of electron, or equivalently represented by the inertia of electron, and they will always overshoot their initial position, which means they will then generate an electric field in this direction. So the electron's movement has to be in this direction. So this back and forth motion of electrons will result in the formation of these oscillations. Okay. So the electric field will exert force. Of course, we have already defined or already derived an expression for the force, which is actually what type of force is it? It is a restoring force. Okay. Right. Now, how do we get an expression for the frequency? What can give us a measure of these oscillations? What parameters can come into picture? Obviously, let's say if we make an intuitive guess of what and all parameters can be part of this expression. See, this is a plasma, so the number of electrons per unit volume can be something, but it can change depending on whether the plasma is a weak plasma or a strong plasma. We can have more number of electrons or ions. So the strength of electric field will always depend on the charge density. So the plasma density has to appear in this expression explicitly. Let's say we call it as plasma density as N, and since it is an electric field, now the measure of the frequency can only be obtained if you derive that second order differential equation for a periodic motion, because there omega square explicitly appears. Whatever that appears as a multiple of that displacement in the second term of the differential equation will be your frequency. Right. Now, let us obtain an expression for that. Okay. The restoring force, because we have to start from the restoring force, the restoring force can be intuitively connected to the amount of charge that is displaced. Okay. So, the restoring force can be proportional to the number of charge carriers okay, per unit volume, of course, per unit volume, and multiplied by charge. Okay, so the restoring force F proportional to NQ. N is the number of charge carriers per unit volume, and Q is the charge per unit per particle. Now, the inertia, the other counterpart which is acting opposite to this force, the inertia is dependent on the mass, no doubt. Inertia is proportional to the mass. Okay. So, the equation of motion for an electron under the influence of an electric field can be me d square x by dt square is qe ex. What is this? This is simply F is equals to me. This is your force EQ, and this is your MA. Right. So now why I have taken only one direction for reference. X is the direction, only along one direction. Okay. Now let us bring the Gauss law. Which is del dot E is equals to over epsilon charge density divided by epsilon naught. We write it in the integral form, integral over a surface E dot ds is equals to q by epsilon naught. Okay, what is the meaning of this? The total charge enclosed within the closed surface. Electric field will be 1 by epsilon naught times the total charge that is enclosed within the closed surface. Okay, now let us go back to the slab. If we have to break this equation, okay, let us say A is the area, or dx dy is A. The coordinate system will look something like this: x, y, and z. The normal is drawn in this direction. This is delta z, this is delta x, this is delta y. So the volume is A times dx dy. Okay. So charge, total charge is rho times the volume. So Q can be written as NE QE multiplied by A multiplied by this delta Z. Oh, okay. I could have written delta Z here. Now using this into the equation, integral over a closed surface E dot ds is E ds cos theta, which is equals to Q by epsilon naught. Okay, so what we have done so far, let us have a recap, so then we will continue this discussion in the next lecture. So we are trying to understand the basic idea of plasma oscillations. Plasma oscillations have to build up on the quasi-neutrality, removing some charge and creating a charge density will lead to the formation of large electric fields, and the role of this electric field is to bring back the electrons, essentially maintaining neutrality. And we realize a simple calculation tells us that the strength of these electric fields, or the force, is very, very large for a very small separation of charges over very small distances. So with this, we constructed a simple thought experiment in which electrons are being removed from one place to another place, and the inertia combined with the electric field will create this back and forth movement of electrons, which are resulting in the plasma oscillations. So subsequently in the next class, we will continue this derivation and obtain a simple formula or simple expression for the plasma frequency.